All right, video number 3. In this video, we will cover protection and how do we use that to make our flushes more efficient. So where do we get started? For now, you'll notice that I've always just allocated the protection bit to be read-write, right? And then the reason we do that is so that we never have any issues when you run the test cases. The test cases will sometimes read and sometimes write, and by setting it as read-write, you'll never get page faults. Well, as long as the page is in memory, then you will in physical memory, then you'll never get page faults. Okay, but in reality, you want to use these permission bits, these protection bits, so that they can help you determine if a page gets written or not. Okay, so let me explain. When can you get page faults? Page. V page. Not in page map. When a V page is not in page map, but your address, like the address that you're accessing, is in, like, requires that virtual page, then you have a page fault. And for now, what we've done is page fault. Here we call aligned p read to read the page into physical memory. Right now, when we read it into physical memory, we want it so that we can keep track of whether or not a page was read or if it was written to. Because if it was written to, then in the flush, we would need to flush that page out. But if it was only read to, we do not want to flush it, right? That's wasteful. That's not, that's just wasteful. So in our previous implementation, where you got all the tests to pass, you flushed every single page that belonged to mcrypt file, like mfile1. Instead, you want to keep track of which pages were written to. So here's a way you can do that using permission bits. There is another way where a page fault can happen, and that is when vpage is in page map, protection is equal to prot read. Okay, so here the page fault is when the page read or write. Okay, and then the way to implement that is use aligned p read. But when that happens, so when the page fault happens, let's have it transition to it's going to be moved into the page table and it has protection prod read. Okay, why is that interesting? When the permission is prod read, if you try to write to that virtual page, you'll also get a page fault. So there's another way you can get a page fault, which is page fault when vpage written to. So when the permission is read and you write to it, that causes a page fault. Okay, so now when that happens, what you need to do in your page fault handler, is you need to upgrade the permission from prot read to prot write, or prot read bitwise or prot write. Right. Now, when you do that, now if you look in the page map, or rather, you can't look inside the page map, but when you look into your auxiliary page map, right? Any change you make to the page map, you're also going to do the supplemental page map. When you see a page is in prot read, you know that it has never been written to. Because if it was written to, then a page fault would have happened and you would have upgraded its protection bit to prot read or prot write. Right. So we know that a page here is accessed, but not dirty. While a page here is dirty. Since, yeah, dirty. Okay, so this is a nice way for you to figure out whether or not a page is dirty or not. Check its protection. If it is prot read or write, you know that it is dirty. Okay, that's assuming that from now on, when you read something into physical memory and you add that mapping into the map, you always set it initially to only read, to read. If it needs to write, then there's another page fault that upgrades it to write. Okay, so at each stage, you only go up one. So you only go from not in map to read, or you go from read to write, to read and write. Okay, because this allows you to figure out which pages were written to and which pages were not written to. Now, what happens when you call a flush? When you call a flush, the dirty pages have to be written, and the not dirty pages don't need to be written. When the dirty pages get written, now all the changes to that pages are already in the file. So even if you get flushed again, those pages should not get flushed. Those pages should only get flushed if someone else wrote to that file since the last flush. Okay, so the definition of dirty is someone wrote to this page since the last flush. So each flush should clear the dirty bit, right? The pages should no longer be dirty after a flush. Only if someone tries to write it again does it become dirty. So every time you call a flush, green, flush. Right, you use use aligned P right. Use aligned P right to flush. When that happens, you want to change the permission bit from read write to just read. And you have to change this for both the page table itself, right, using the VM region map function. And you have to also change it in your supplemental page table, because that's the table you use to figure out which pages need to be written to. Okay, now remember, there's a note on the misc notes. After flush, the pages still remain in memory. Okay, this does not happen. This does not happen. Only this. So once a page is in the page map, it will remain there forever, at least for this project. In the next project, then we'll deal with other arrows, right? Because then you can actually, this arrow might happen. Or, there's another protection mode you can use called prot none. So we actually add a fourth one in here, prot none, which signals that a page is not accessed and not dirty. Okay, cool. So yeah, I mean, this should be sufficient to implement the protection, right? Just instead of giving everything read-write access, when you page in using align p-read, only give it read protection. And then if the page fault handler happens again, then you upgrade it to read and write, read or write. So now your page fault handler might be called multiple times on the same page, right? The first page fault happens when the page is not in the page table, so it gets moved from the file into the physical memory. So that's the first page fault. Then you try to write something to it, and it's in read mode. So another page fault. Your page fault handler needs to upgrade the protection from read into read or write. Okay. What is important about that is that you need to be careful about when you are calling aligned p-read. You only call it the first time you move it from the file into physical memory. Okay. Once it's already in physical memory, you don't call align p-read. So if you have bugs, one more, p-read and page alloc. Okay, so if you have bugs if there's some weird thing about the tests where you are reading too many pages from the file, right? At the very end of each test, there is a how many pages did you read? If that number is too high, that probably means you are calling align p-read too often. Multiple page faults can happen for the same page. So you need to have some conditionals to check whether or not you are in this first case, in which case you do use align p-read and page alloc, or if you're in the second case, in which case you only need to update the protection bit. Remember, any change you make, you always update the page table and the supplemental page table, because you need the supplemental one to decide which pages are dirty to evict, not to evict, to flush. Okay, I think that is it for this project. Let me double check. Let me switch my screen. And let's see if there are any other things to worry about here. So inside, yes, so this is essentially what I'm referring to, dirty bit mechanism. Oh yeah, in my table, I wrote that you needed an explicit dirty bit. I think it's up to you. Like, you can have an explicit dirty bit and an explicit accessed bit that you modify based on the permission. For me, I just use the permission itself as a proxy for if it's dirty or if it's accessed. Okay, so up to you if you want an extra field there. I personally did not make one. Yeah, and this part was referring to when you flush something, it's no longer dirty. So you have to switch from read write back to just read. Cool, I think that's it. Oh yeah, but I think maybe just to be super clear, let me write let me just show you what the protection modes will look like. So let's do the example again. Initially, we read the map. So initially, when we try to read from 5,000, so what happens initially is this becomes the read, right? We first move that page into physical memory, so that becomes our protection read. And since we were just reading, that's fine. That is remaining a read. Then what do we do next? We created mcrid file 2, m file 2, and then we tried to modify recipe that 0x80. So it's this one. When the contents are first brought into physical memory, this is initially in the read state. And then you try to resume the instruction and you get another page fault because you were trying to write, but the page map said you can only read. So you run the page fault handler, and your page fault handler needs to upgrade this to read write. Then the instruction resumes and you're able to successfully write there. Same case for the other two, right? The other two, we're doing the mem set. So first, page fault, because they're not in memory, you bring them into memory and they initially have the read protection. Then you resume the instruction, you try to modify, page fault again, because you're in read mode. So you run the page fault handler again, which is responsible for upgrading to read write. Remember, you don't allocate a new page just because there's a page fault. You only allocate a new page when the entry is completely not in the page table. Okay, if it's already in the page table, don't allocate a new page. Instead, just upgrade the permission. Same deal for this one. First page fault, you bring the page in, turn it into read mode. Second page fault, you upgrade it to read write mode. Then when you call flush, M1 flush, you can look at which ones to call flush. Oh, yeah, this same thing happens for, you save this same thing down here. So read write. Every time you modify the page map, you modify the supplemental page map so we can keep track. You can also set the present and dirty bit. So present is always 1 for this project. Dirty, up to you if you want to set your own dirty bit or if you just want to use the protection, but it's dirty whenever there is the write mode on. Now, when you flush, you can figure out first which pages belong to your file. We only care about M1 file. So you have to only care about these two. And then you only want the dirty ones. So out of these three, the only dirty ones are these bottom two. So the only two you have to flush are these two. You do not flush the first one. In our previous implementation, we flushed the first one. That was inefficient. So now just make sure you flush these two. You don't flush the first one because it's only in read mode. It's not dirty. After the flush, what should happen? After the flush, the pages that were written out to were flushed, go back to read mode, and they are no longer dirty. They will become dirty again if you try to write to them again. All right, we've done an explicit example. Hope that was helpful. And I think we're done. All right, congrats on working your way through all these videos. I have no idea how long the videos have taken, probably a long time. So thanks for watching. I hope you have a fun weekend and early next week working through this project. It's a lot of fun, and I feel like it's conceptually very interesting. All right. Well, yeah, once again, like, subscribe these videos or whatever you do on YouTube. And I hope to see you next week when we do the Project 6 video. I'm just going to record that right now. I might as well get all the videos done. All right, bye.